In this module, you will learn about the conic sections that are formed when a plane intersects a cone at different positions and at different angles. When we talk about a cone, the first associations that come to mind are ice cream cones and birthday caps. Now, let us look at a cone from the mathematical point of view. Consider a fixed vertical line L. Now, consider another line M that intersects line L at a fixed point V. Let the angle at which line M is inclined to line L be alpha. If line M rotates about point V such that angle alpha remains constant, it generates a double cone as shown. Such a cone is called a double right circular hollow cone. In this module, we will refer to this solid figure simply as a cone. Let us identify the different parts of a cone. The fixed vertical line passing through the center of the cone is called its axis. The rotating line M that generates the surface of the cone is called the generator. The fixed point at which the generator cuts the axis is called the vertex of the cone. The cone is divided into two parts by the vertex. The upper part is called the upper nape, and the lower one is called the lower nape. When a plane intersects a cone, it cuts a section from the cone. This section is called a conic section or a conic. We get different kinds of conic sections of different shapes depending on the position of the intersecting plane with respect to the cone and the angle it makes with the vertical axis of the cone. Consider a plane that intersects a cone at any position other than the vertex and makes an angle beta with the axis of the cone. Now, we have several possibilities. If the plane intersects one nape of the cone at right angle to the vertical axis, the resulting conic section is a circle. If the plane intersects one nape of the cone such that angle beta is greater than angle alpha, but less than 90 degrees, the resulting conic section is an ellipse. If the plane intersects one nape of the cone such that angle beta is equal to angle alpha, the resulting conic section is a parabola. If the plane intersects the cone such that angle beta is less than angle alpha and greater than or equal to 0, the plane cuts across both napes of the cone, and the resulting conic section is a hyperbola. Observe that in the formation of conic sections in the form of a circle, ellipse, or parabola, the plane intersects only one nape of the cone. However, in the formation of a conic section in the form of a hyperbola, the plane intersects both the napes of the cone. Also note that in the formation of these conic sections, the intersecting plane does not pass through the vertex of the cone. Conic sections have a large number of practical applications. Historically, the circle has provided momentum to our economic and industrial development. The ellipse is used extensively for studying planetary motion and making advanced reflectors for automobile headlights. Parabolas are used to study the trajectories of projectiles. Hyperbolas are used to study sonic booms created by supersonic aircraft and to study the propagation of waves and movement of subatomic particles. Thus, the study of these conic sections finds many practical applications in different branches